Now, this example is going to help you do problems like example 3, but a lot faster. But to be able to do them, you have to know you have to know what a matrix is. A matrix is a rectangular array of numbers. Huh? Pretty much, it's numbers put into a rectangle. And so, for example, let me show you a matrix like 5, 0, 1, 2, 4, 6, -3. And you can also have fractions in there. Any types of numbers can go into a matrix. They probably need to be rational, though. Okay, so rectangular array of numbers put into a rectangle. That's what a matrix is. One thing you need to know about matrices, first of all, matrices is the plural for matrix. You also need to know how to name a matrix. So our matrix is named by the number of rows by the number of columns. And rows go horizontally back and forth. Columns go vertically. So if you think of like columns on a building or on a house or on a mansion, the columns go up and down, rows go left to right. So this matrix right here has 2 rows and 1, 2, 3, 4 columns. So I would call that matrix let me point an arrow to it over here, a 2 by 4 matrix. So that's how you would refer to each part. Now, why do you need to know about matrices? Because matrices are going to help you solve systems of equations really quickly. But you need to be able to set them up. So there are 2 ways to set up a matrix. So I'll show the first way and then the second way called an augmented matrix. Okay, so the first way to set up a matrix is to set it up as the coefficient matrix, a matrix equation. COEFFICI, coefficient matrix. So coefficient would be referring to the coefficients of the variables. So for example, A, my coefficients would be 3, -1, -2, 7. And you put those coefficients in the same position that they are in the system. But you got to make sure that they're in the same order. So the x's need to be stacked, the y's need to be stacked, the equals need to be stacked, and the constants need to be stacked, just like they have to be stacked for the elimination method. So that tells me what the coefficients are. After that, you would say, okay, well, that's equal or, well, next to the variable matrix. So coefficient matrix written beside the variable matrix. The variable matrix are the variables that you're using. And you read variables left to right, but when you list them in the matrix, because of the way that matrices work, you need to list them in the same order that they appear, but you need to list them vertically. And I'm just going to tell you you need to do it this way, because later on in the year we'll study more about matrices and you'll know why you need to write them this way. But for right now, if you can just be okay with knowing I need to put, if my x comes first and then the y, then when I set up in my equation or set it up as a matrix, the x has to go on top and then the y. Then you'll say that equals the constant matrix. And again, I'm just showing you how to set it up. So equals, and my constants are the numbers that don't have variables, 4 and 20. So 4, and you put them in the same position, 20. Yay. So that's one way to translate, because all of this question is doing, it says write the matrix for the system of equations. So that we're practicing turning a system into a matrix so that later on you can use the matrix to solve. So that's one way to set it up. The other way is to do something called an augmented matrix. And an augmented matrix shows all the coefficients and constants in the same matrix. So, all the coefficients and constants. And again, coefficients are the numbers in front of the variables. Constants are the numbers outside. Now, it shows all the coefficients and the constants, but the way that you do it, it's going to look similar, but you'll have like your coefficients. I'm going to abbreviate them coefs, and a dotted line, and then you'll have your constants. But you'll put them in the same position that they appear in the system. So for example, in the system, I see 3, -1, -2, 7. I'm going to do that over here. 3, -1, -2, 7. Then I have my dotted line. And then my constants 4 and 20. And you'll close it. And this again is called an augmented matrix. So two different ways to translate a system of equations into a matrix equation. And your homework will specify which one they want every time. So just be aware of that. Now, part B, it says we have to go the other way. I need to take this augmented matrix and turn it into a system. Well, I can see that there are 3 lines, which means there are going to be 3 equations. I can also see that there's 3 rows. So that means there'll be 3 variables. So 3 lines means 3 equations. 3 rows, when I say lines, I should say columns. 3 rows means 3 variables. So my variables might be X, Y, and Z. They didn't assign a specific variable, so I'm assigning them myself. Okay, so my first equation would be 0x plus 2y plus 3z equals, and then I pull a 4 from right here. So this right here is my first equation. Now, you don't have to write that 0 there, and in fact, you're probably not going to see it written. So it won't appear. But you do have to know if there's no x, but the other equations have an x, you need to insert a 0 into your matrix. Okay, the second equation will be 8x minus 1y minus 2z equals 5. It's the second row. The third equation will be 2x plus 0y plus 1z equals 9. And again, anytime you have a 0 as a coefficient, we're not going to write it because it's understood to be there. So you'll just see 2x plus z equals 9. And this is our system. Now, if you want to see more examples, stay tuned. Otherwise, move on to the next video. Okay, so I flipped a couple of pages. I'm on page 46 now. I can look at number 25. It says I need to turn that into an augmented matrix, but notice how I don't have the variables stacked on top of each other. So I'm going to rewrite this equation. I'll subtract 2x on both sides to get negative 2x plus y equals 0. So that allows me to see the variables over top of each other and then the rows. So I set up my matrix. My coefficients are 4, -1, -2, -1. The constants are 9 and 0. And that's my augmented matrix. Then something like, is there a better example? Nope, we'll just do, I think, 28. Let's make an equation based on this. Again, so there's no letters assigned, so I'm going to assign it x and y. First row is my first equation, so 2x minus 2y equals 4. Second row is the second equation, 1x or x plus 2y equals 11.